So our first talk is by Marcin Wągiel and Pavel Caha, called Decomposing Cardinal Numerals, Cross-linguistic Evidence. So please feel free to go ahead and share your screen.
Okay, hello. I'm gonna be giving the talk by myself. I just got a phone call recently from Marcin that he had some kind of an emergency. And so I'm gonna be improvising a bit, and so please bear with me. And so our talk started as a general cross-linguistic investigation of two different functions of numerals across languages, which we're going to be calling for abstract counting function, as exemplified in 1. For example, 10 divided by 5 equals 2, or 5 is a Fibonacci number, where the numeral refers to a number concept. And we're going to be contrasting them with what we're going to be calling an object counting use of the numeral, which is reserved for quantification over entities. For example, as in examples like 5 cats and the 5 girls. And so clearly the examples 1 and 2 are conceptually different. In the first case, you refer to a number. In the second case, you use the numeral.
I think you need to share a screen.
Oh, thanks a lot. Good. Can you share my screen now? Can you see my screen now? Okay. Okay. It's okay now. Okay. Thanks a lot. And so the examples are in 1 and 2. So 1 is the abstract counting use. 5, 10 divided by 5 is 2. And the example in 2, object counting. And so they are conceptually different. And now the question is, are they also linguistically different? And the answer we want to say is yes, they are linguistically different. And so first of all, and we're going to be asking what's the relationship between them. And the answer we're going to propose is that they cross-linguistically show signs of the abstract counting numeral being simpler than the object counting numeral, both in the morphological and syntactic and semantic senses. Okay, and the way we are going to be arguing for this position is we're going to be looking at the relations between the two types of numerals, and we're going to propose a particular meaning decomposition of the numerals and how they're morphologically realized. And so, just as I said, we're going to start by giving reasons to think that these two different uses are actually linguistically different. And the first indication is that you can use the numerals in one sense felicitously in some contexts, but not in others. So for example, you can say 5 times 2 equals 10 using the abstract counting numeral, but we cannot say, or it sounds odd to say 5 things times 2 things equals 10 things. And so in these mathematical statements, the object counting numerals are not felicitous. In statements such as 4, for example, you can say 5 is a Fibonacci number, but we cannot say 5 things are Fibonacci numbers. So there are some contexts which are reserved for what we call abstract counting numerals, and we look at those contexts in order to identify abstract counting numerals in languages. There are more properties which I'm going to skip in the interest of time. And I think that, yes. Okay, and the basic thing that we're going to be looking at is how these two different functions are morphologically marked. And in our previous work, we have been looking at the differences between abstract counting and object counting numerals. And we were mainly looking at simplex numerals, that is when the abstract numeral is a simplex thing, and then you can get the object counting numeral looking the same as the abstract counting one, and so there is a syncretism between the abstract and the object counting uses. And you can also get a morphological relation of stacking where the object counting numeral is more complex than the abstract counting numeral, and you can get also suppletion where the object counting numeral is morphologically unrelated to the abstract counting numeral. And where we think that Austronesian is particularly interesting is that we found quite a few examples of cases where already the abstract counting numeral is morphologically complex, that is already at the level of the mathematical statement, you have numerals that actually contain multiple morphemes. But that seems to be pretty much, as we will try to show, the only main difference between Austronesian and the rest. Because then when you look at the relationship between the abstract and the object counting numerals, you find pretty much the same pattern. So sometimes the object counting numeral is the same as the abstract counting one, which means having two morphemes. Sometimes you find stacking. So in addition to the two morphemes, you have to add a third one, just like you had to add another morpheme in the object counting use in the simplex languages. And you also find suppletion, which in this particular context is marked as replacing by the second morpheme B for C. Okay? And sometimes we will see also examples of replacing the first morpheme, but we will not really go into such a detail. So we're going to start by showing the simplex numerals and syncretism between in the simplex scenario where the object counting the abstract counting numeral is simplex, 10 divided by 5 equals 2, and the object counting numeral as in 5 cats is identical. So this is syncretism, and we know that from English. And we show here another example from Abui, which is not Austronesian, but it's kind of an adjacent area. And we couldn't really find good examples in Austronesian. We suspect some, but it's always very difficult to find examples of the abstract counting use in grammars. And so we have no example from Austronesian for this. Then we move on to stacking. And so we find examples of stacking in many classifier languages, but also in some non-classifier languages like Yoruba. And so take a look at 8. And this is an example of an object counting use. So we are counting apples, and the numeral in 8b is go-ko. It has this morpheme ko. So go is the numeral root. It has an additional morpheme ko that's usually called a classifier, and it has to be used, this classifier, in the object counting use. However, if you have a mathematical statement in Japanese, such as 10 divided by 5 is 2, you have to drop the classifier, and so you only have the go as in 9a. Okay, and so we have a simplex numeral in the abstract counting use, but we have to add this classifier ko in the object counting use, and so we call that stacking because the object counting use has an extra morpheme. Possibly we find this situation in Tagalog, but here I'm just going to give you the examples. So we have in 11 a sentence 2 plus 4 is 6. And we were a bit struggling here with the glosses because we have that from a conversation handbook. Nevertheless, we hope that the glosses are correct. But the important thing is that this form dalawa is the form of the numeral 2 when you use it in a mathematical statement. When you look at 10, this is the object counting use, and you have this morpheme, extra morpheme there, ng, which is called the ligature, and which appears in between every two members of a noun phrase, including between a numeral and a noun. And we're not really sure whether we should analyze this as some kind of specific numeral morpheme like in Japanese, or whether it's a general linker. So we're just putting this on the side. We're moving on to the last pattern for the simplex counting numerals. And this is in Maltese. So for example, if we are counting objects like two women in Maltese, you have to use the form of the numeral zeuch. Whereas if you have a mathematical statement like 2 and 2 make 4, instead of zeuch, you cannot use zeuch. As you see in 13b, you have to use this numeral name. And so there is a suppletive relationship between the two numerals that you use in abstract counting and in object counting. An interesting, perhaps related case, although we believe to be different, is maybe found in Puyuma. And this is the pattern. And so for Puyuma, we don't have an example of an arithmetic context, but there is a difference between so-called serial counting numerals, okay? And we don't know whether the serial counting numerals are used in mathematical statements. We suspect that they are not. And so the serial counting numerals are, you use them when you say count 1, 2, 3, 4, 5, and so on, like in a row. And there, for example, for the numeral 5, you use the root as given there in the blue, beginning with the erotic labial L, liquid L. And then for object counting numerals, you always have to add a classifier in Puyuma. The MIA is a classifier for animate. There is also a classifier for inanimate. But the interesting thing is that the shape of the root is different. So there does seem to be some kind of a suppletion going on. So when you count objects, like the 5 of them, the 5 brothers and sisters, you have to use this form Mia Luvata. And so there is some suppletion going on. Now, where we found most interesting data in Austronesian is when it comes to the fact that already the abstract counting numerals are complex. And so these are data from Hawaiian, and the numerals in Hawaiian, as they're giving in the basic form, they already have 2 morphemes. And so they have this prefix e, followed by a particular root. And we can see that this e is a prefix because when you use the numeral in the distributive sense, like 2 times, you change the prefix for a different one. However, or interestingly, it's very different from Japanese, where you only have this bicompponential numeral in the object counting use. So we are used to having complex object counting numerals with some kind of a classifier. But in Hawaiian, also when you make arithmetical statements like 2 plus 2 is 4, you use this prefix on the numeral. Okay, so already in the abstract counting use, in this 2 plus 2, the numeral is complex, and we have not seen that before. Similarly, in Veraa, we have numerals where the cardinals have this prefix vo until 5, I believe. And we can see again that vo is a prefix and the numeral is bicomponential because in the multiplicative use, you have a different prefix. And here we have what resembles to us an arithmetical use. So the mother counted waves reaching the number 3. And so here the number 3 is morphologically complex. And then when you use this numeral to count objects, you add this ligature. This ligature ne that comes on top of the bicomponential numeral is specific to the numeral. So it is not like the one in Tagalog, which appears between every 2 members of the noun phrase. This ligature appears specifically between a numeral and the noun. However, we should also know that it is optional, and the author of the grammar knows that when it is dropped, it resembles some kind of a lexicalized collocation. So I think like 7 days is some kind of a special 7 days celebration or something. So that's the example he gives. Okay, and so finally we move on to suppletive cases, which we illustrate here by Mokilese. And the pattern is like this. So when you look at 21, this is an abstract counting use. And the numeral in the abstract counting use, you see it has 2 morphemes, pa and w. And so already in this is again complex. And then this w is called a general classifier. And so when you count objects, you can also use this general classifier, but you can also use more specific classifiers, replacing the original classifier. And so we classify this as a kind of a replacive language, where the abstract numeral that is morphologically complex, okay, this w here has a suppletive allomorph man, okay, for the object counting use. And we analyze it this way, even though it's not a clear case of suppletion, because also here we have this w in this particular use. It's not a clear case of suppletion. Nevertheless, what we want to capture here is that this additional classifier man does not come on top of the w, as it, for example, could in Veraa and so on. So we call this a suppletive pattern as opposed to a stepping pattern. Okay. And so to summarize, these are the patterns. So we have simplex numerals where in this abstract column, they are, monomorphemic. And then for the object counting numerals, you either have a syncretism, that is the same numeral, or you have the stacking pattern where you add the classifier or you have a suppletive pattern. And basically what we seem to find in these additional languages that we were talking about is that already the abstract counting numeral is morphologically complex. And then again, in the object counting use, it's either the same, remaining morphologically complex, adding additional morpheme, just like Japanese would add an additional morpheme, or replacing one of these morphemes by a suppletive counterpart. Okay, and so this seems to be the pattern that we would like to capture. Now, here I'll be missing Marcin very badly because this is the semantic analysis that he is the main author of. And the main analysis, I really will skip the details here. The main analysis, I will go directly to the structures. So the main analysis that we are proposing is that at the core of each numeral, there is a scale. Okay, so the numeral is, there is a numerical scale, if you wish, a scale of quantity. And when you construct an abstract counting numeral, you do it by applying this num head to the scale, providing that particular individual that's found on that scale as the abstract counting numeral. And when you have that individual, okay, and this is the arithmetic numeral referring to a particular entity, you can apply an additional classifier head, which turns it into a counting function. Okay, and I will have to skip the semantic details, which I'm not really the person to talk about. What my part of the talk was mainly going to be about is how we can assume this, and so we would assume that these components of the numerical structures are universal. And the way the variation comes about is by varying the lexicons of individual languages. And so we will have a mechanism which will basically be a lexicalization procedure. It's an invariant lexicalization procedure that takes these structures as an input, looks into the lexicon, and produces a language particular output. Okay, and the way we do it is we use the nanosyntax model of spellout, which is a realizational model of morphology. The purpose is to map the structure to pronunciation using lexical entries. We're relying on cyclic phrasal spellout and on spellout-driven movement. I will spare you the technical details of the analysis, but I will try to give you the gist of it. And the gist is here. So the gist comes in the form of what we call a lexicalization table. Here on the left, you have the abstract counting numeral. The abstract counting numeral has two meaning components, the scale, the numerical scale, and then the particular numerical value on that scale, and that's the abstract counting numeral. The object counting numeral has one additional meaning component, this CL, that turns that individual into a counting device. And the idea about syncretism is that this particular exponent 5 is ambiguous. Sometimes it can pronounce all three meaning components, and sometimes it can pronounce just two. And so this morpheme either lexicalizes 3 or 2 components. Technically, this comes out as a result of phrasal spellout. And so we perceive of lexical entries basically as links between syntactic structures and phonological form. And so the idea is that this lexical entry tells you if syntax, okay, there is a technical insertion procedure, which I'm going to paraphrase now. If syntax produces a particular structure, as you see now on the right-hand side, it's identical to the object counting numeral. It has all the three meaning components. When syntax produces something like this, goes to the lexicon and says, can I map this onto PF? And I can map this onto PF if a constituent like this is contained in the lexicon. And so here there is an identical constituent in the lexicon. And so yes, I can map this object onto the pronunciation 5. And that's the meaning of the thing. Syncretism comes about like this. You construct an abstract counting numeral, has only two meaning components, lacking the CL. And you again go to the lexicon, can I map this onto phonology? The lexicon says yes, if your lexicon has a constituent that is identical to this, and there is a constituent identical to the abstract counting numeral, and it can be linked to the phonology 5. Okay. And so that's how the syncretism comes about. I'm going to briefly show you how the suppletion comes about. It comes about as a result of having two different lexical items for a single numeral in the lexicon. We have the zeuch in 33, which is the same as the English numeral, and we have that name, which is a dedicated numeral for the abstract counting. When syntax constructs an abstract counting numeral, we go to the lexicon and we say, is there a constituent that's identical to this? And the lexicon says, yes, this constituent is in fact contained inside two lexical entries. And so there is a competition and you choose the most specific one, which happens to be name. If the syntax constructs the object counting numeral, adding this extra meaning component, you again go to the lexicon. You say, is there something that contains this constituent? You say, yes, there is zeuch. Now, I know I'm going over time. Bear with me just 2 more minutes. I'm going to give you a couple more details and then I'll round up. So what we have so far seen is how the syncretic and the suppletive numeral come out. I will now describe the stacking pattern, and then I will just give you the gist of the analysis without the technical details. And so the idea again is that the only difference really is in the lexicon. The spell-out procedure is going to be the same. So in Japanese, the root of the numeral, remember Japanese is a stacking language, you will have to add a classifier. So the numeral root that you see in 36 does not contain all the elements of the meaning of the object counting numeral. It only contains the abstract counting numeral. And so when the structure of the abstract counting numeral is produced, you ask the lexicon, can I map this onto phonology? The lexicon says, yes, I have an identical constituent. I can map this onto phonology. But then you add this additional meaning component, okay? And there is a spell-out procedure which says, now try to pronounce what you have produced. But the lexicon says, I have nothing that matches this constituent. And so the spell-out procedure says, well, if you don't have anything that matches this constituent, try to change the structure by movement. And you see this in 38b, if matching fails, you try to move the complement of the CL head, and then you retry the spell-out, okay? So the complement of the CL head is numpy. I will now move it to the left. So I have taken it now out of the CLP. So the CLP now just has a single daughter, okay, because the second daughter had moved out. And now I ask the lexicon again, is there a spell out? And the answer is yes. And it's the classifier call, okay? And so basically what I just tried to tell you is we use this procedure to map the structures onto outputs, okay? And what I will now skip is the technical discussion of all the numerical types. And I will go to this final table where basically what I want to show you is similar to what we've seen in Japanese here. In Japanese, this numeral go was specified for 2 meaning components, and you needed a specific special marker for the third meaning component. What we're proposing for the languages that are complex in the abstract counting sense is that their root only spells out the scale component, and they need an additional component already in the abstract counting use. Okay, so the reason they're decomposing the abstract counting numeral into 2 meaning components is because of the morphological complexity. We're going to store it as very small in the lexicon, and so you will need an additional morpheme here. And then in the object counting use, there's going to be a similar story to the one I told you, okay? And so just to conclude, so we started by the question, what's the relationship between object counting and abstract counting numerals? The answer is the morphology seems to tell us that the object counting numerals syntactically and semantically contain the abstract counting numerals. And the gist of the proposal is we try to capture the patterns that we find using this tri-componential structure for the object counting numerals and a bicomponential structure for the abstract counting numerals. And we have a mapping procedure how to map this input onto various types of outputs. And so thank you, and sorry for going over time.
Okay, let's thank our speaker. We've got about 5-6 minutes left for questions. So as always, you can raise your hand or write them in the chat, in which case I'll read them out. Go ahead, Elena.
Hi, thanks. This isn't really a question, it's more a comment, and I don't know how useful it is for you, but I'm pretty sure that Malagasy has the syncretism across the two, and they're not morphologically complex. And Ed Keenan has this wonderful collection of like textbooks written in Malagasy. So I'm sure he could find you many examples of how to say 1 + 1 and these kinds of things. He loves that kind of stuff.
Thank you very much.
If you're looking for data, I would contact him.
Yes, thank you very much for both the data and for the source. I mean, we suspected Malagasy has that pattern indeed, and we even found some suggestions, I think, suggesting that the end is used for plus, but we couldn't really find an example that to present. So it's very good that we have the Keenan reference. Thanks so much for that. That's very useful. Thank you.
Go ahead, Henderson.
Thanks for that talk. I guess my question is more out of curiosity. I was wondering if you have anything to say about languages where there's like at least two systems of numerals, one of which is, say, a borrowed system, and because I guess often what happens is they get used in different contexts. So I'm thinking, for example, in Tagalog, we have the I guess you can call them the Austronesian numbers, which are used in, as you mentioned, like in counting and maybe also in these kinds of mathematical examples. But we also have certain contexts where Spanish borrowed numerals are used. And I'm wondering if you have any thoughts about what's going on, if your analysis kind of has anything to say about that kind of use.
Yeah, so thank you very much for the question. So what often happens, or what we have seen quite often, is that the descriptions are such that for counting objects, people use native numerals, or what the linguists would classify as native numerals. And for mathematical counting, people would use borrowed numerals. But as you described Tagalog, and that has to do with the schooling system and so on and so forth. And that's, for example, what Jessica Kuhn told us about the Mayan languages, where Spanish would be used in schools as a language of instruction, and so also for arithmetical counting. And there, I mean, we're not really sure what to think about it. It would be perhaps, could be thought about as a suppletive pattern, but we are not really sure that this is what's going on. And in fact, in Tagalog, we noticed by reading through the grammars, exactly what you're pointing out is that, for example, for, I mean, the grammar specifically mentioned, for example, that for counting money, people would use often the Spanish numeral. And so there it didn't really seem to be tied to the difference between the object counting and the abstract counting. At the same time, what we also noticed is that very often measures behave differently from object counting. So it's something different to count ethos and to count meters or count kilos or bags or something like that, right? Not always. Sometimes counting meters is the same, so it cannot be. It's not identical to the abstract counting, and it's not identical to the object counting. And we are not sure also where money belongs in this kind of a system. So perhaps if there are these more difficult facts, you know, where the numerals, for example, for money seem to pattern with the abstract counting numerals, that may have different reasons. Having to do with money being used as some kind of abstract measure of the value of things. So, I mean, that's the kind of a general thing that we noticed, but yeah, I don't know about Tagalog specifically. We haven't looked at in enough detail. thank you for the remark.
Okay, so it's 11, so we can leave further discussion for the Slack channel. So let's thank our speaker one last time.
Thank you.